And that recording isn't going anywhere. It's just for us over here at Beta to have a record of the class, and it's going to be sent out to you guys via email at the very end of the class, along with a copy of the slide deck. Right. So now we're going to take a look at today's agenda. So this is just a brief walkthrough of a little bit of everything that we're going to be doing today. So first things first, we're doing our welcome introduction. So in this course, we're going to be delving into the New York City motor vehicle collision data using the New York City Open Data platform. We really like this data set because it's a really helpful way to showcase the many different uses and capabilities of the New York City Open Data platform. And it's pretty relevant to all of us as New Yorkers because we all use the roads. If you want to get anywhere, you're crossing the street, moving past traffic. So it's in everyone's best interest to know where the safest place to walk is. We're going to be taking your questions in the chat throughout the class, but we also have a designated time at the very end of class reserved explicitly for questions and supporting you guys in navigating and using open data if you have anything at all. All right, so now we're going to just look at some acknowledgements. This data journey was adapted from the Open Data Ambassadors curriculum, which was co-created by the Office of Data Analytics at the New York City Office of Technology and Innovation, also known as OTI, and the civic technology organization BetaNYC, which is myself and Kate. All right, so now moving forward a little bit, we're going to actually take a look into the past with a brief history of New York City open data. So what is open data? Defining open data can be quite simple. It's the effort of making government data accessible to the public. Because of its connection to data, just with its terminology, it's often thought of as a 21st century phenomenon, one that accompanies the growing importance of data in our everyday lives and stems from the increased creation and use of data by governments, both in New York and around the world. In fact, there's actually a really long history of similar efforts to make government more accountable and transparent. So to better understand how we got here, we're going to briefly touch on some developments that led to New York City open data. And first things first, we're just take a quick look at this picture. Very busy, a lot going on. So what is this? This is our way of showing you what data is. Data is everything and everywhere. If you look at that street, you'll see that it is marked by the Department of Transportation. If anything is to happen to that street, needs repairs, there's something not working with the traffic, the Department of Transportation collects that data, makes sure that everything's up and running so that everything's fixed. Every single trash can you guys walk past, that's a data point for the Department of Sanitation. Every single building, Department of Buildings. Every single thing that we walk past is just a singular point of data. So that means there's a lot of it. So what the open data platform does is it helps consolidate and allows us to manipulate that data so that we can actually make something meaningful of all of the raw data that's around us all the time. All right. So next slide. Thank you. So specifically, what is open data? Open data refers to data sets that are freely available for anyone to use, modify, and share, typically without any restrictions. This means the data is accessible to the public, including individuals, businesses, media, and consumers. So now let's take a quick look at the roots of open data and some of the milestones in government transparency, which started back more than 100 years ago. So the root of the open data movement, especially in New York City, can actually be traced back to good government efforts that date back to at least the late 1800s and the progressive era of government reform. In New York City, these progressive reforms created a new government newspaper to share city notices and updates. This newspaper, known as the City Record, publicized things like what the city agencies were looking to buy, who they recently hired, and what public meetings were about to happen. This city record was proven so useful that it's still being published today, both in print and online. And we're going to drop the link in the chat so that you guys can take a look at it if you want to. And the reason that this was so revolutionary for the time is because this was the very first effort that the government was making to include the everyday citizen into what was going on behind the scenes. And this was only furthered as we continue. So government information, of course, goes beyond these updates on daily business. Jumping some decades ahead to the 1960s and 70s, freedom of information legislation, which you might know as FOIA or FOIL, FOIL, was being passed by federal government and also by state governments, including New York. FOIL made government information available by request. If you know what you're looking for, you'd be able to ask for it. And if the information exists and could be shared with you, it would be. In some cases, the not public records are shared more widely, for example, published in an article, but often the only person to ever see those records would be the individual who requested them. With FOIL, most government information is available if somebody asks for it. And at the time, this was a completely revolutionary concept. There had never been any effort before that would have allowed for the everyday citizen to gain access to the information that the government had on standby. So you can see here that there's an example of the kind of information that was made available due to freedom of information requests. So that document right there is from the FBI's investigation into Martin Luther King Jr.'s assassination. And a more recent example would be the documents concerning the assassination of JFK becoming unclassified and released to the public. So moving forward now, one of the challenges with filing freedom of information requests is that, simply put, you don't know what you don't know. You can't put in a request for something if you don't even know that it exists. So in order to solve this problem, in 1993, New York City released its public data directory. This directory made a subset of the information available through FOIL, information stored as data, more accessible by providing a listing of what data agencies have. Someone could now see a listing of what data was available at each agency, read a description of what it contained, and use that knowledge to help inform their FOIL requests. Interestingly, some of these systems and databases outlined in this directory still exist to this very day and are continually updated and maintained. So moving forward now again, by 2012, advocates, city staff, and elected officials came together to pass New York City's open data law. While many cities have open data as a policy or executive order, New York City's law guarantees that the public will have access to the information in perpetuity, regardless of administration. A key difference between open data and FOIL is that no one needs to ask for the information. Anything that meets the definition of this law is required to be made public by default and is shared with everyone on the New York City Open Data website, meaning that information wouldn't just be stowed away in private. Every single thing that was deemed acceptable for the public was immediately published and granted access to. So now we're going to be transitioning over to Kate as we go through a basic walkthrough and navigation of the New York City Open Data website utilizing the crash data set.
There we go. Yes, I'm unmuted. Hello, I'm Kate. I am also a master's in social work student like Giuseppe at Fordham. I am also about to graduate this May, live in Manhattan. I have been doing my social work field placement as a junior associate at BetaNYC since September. So we are going to take a look at one of the many applications of open data, which is the NYC Open Data website. I'm going to throw the link into the chat, but you should also see it on my screen, I hope. I think you do. And so this is the NYC Open Data website. This is their homepage, a little just basics on how to navigate the page. Very obviously, there's a search bar right here where if I already have a sense of what I'm looking for, I can just search for a keyword or a search term in this search bar here. If I want to browse and see what's available, I can go to the data tab in the upper right-hand corner, click there, and then it gives me a series of data sets I can search through. So I can start with looking at the newest or the most popular, or I can search by category. So if I know I'm interested in something having to do with education, I might start there. Or go a little bit more refined, I can search by agency. So if I know what agency probably publishes the data set that I'm looking for, I could also start by scrolling through agency. Over here, in our case, I actually do know what I'm looking for, which is information related to car crashes. So I'm going to search in the search bar. And then I get in this case, 17 search results, some of which may be completely unrelated to what I'm looking for, some of which may be published by the same agency as what I'm looking for. I am just going to go to the first series of results here where it says motor vehicle collisions, crashes. And that takes me to the primer page for this data set. So a couple of things that I notice off the bat when I get to the primer is the date last updated. So this data set was last updated on April 25th. I can get a sense that it's probably updated pretty regularly. And the information is being provided by the NYPD. Scroll down a little bit more. Again, I see the date that this set was last created or last updated. I can see the date created. So ironically, we're just about at the 11th year anniversary, if I'm doing math right. It's been 11 years since this data set was published down to the date. I also can see how many times it has been downloaded, a little bit more on who's collecting the data, who's publishing the data. Looks like it's updated daily. I think Mondays probably, or Saturday, weekends probably don't count in the daily, but during weekdays, we'd expect it to be updated about once a day. If I scroll down a little more, I can see the size of the data set. So it contains 2.17 million rows of data, which is very large, probably larger than any of us could meaningfully make use of if we were to just take it out of the website in its raw form. But it also has quite a bit of information about each individual crash. So every one of these column names corresponds to a piece of information about an individual crash. So for each individual crash, which would be a row in the data set, we can see that we would learn the crash date, the time, the borough, really down to the specifics of the location. Can learn it's, of course, hard to think of the human element in this, but if there were any injuries that resulted from a crash, we would see that information as well, presented as a column. And then if we go a little bit farther up, we see every data set should have this linked to a data dictionary, which we can click on to download. And then I have to change my sharing settings so that you can see it. First, I'm going to stop share. There we go. Not that guy. And then share again. And now you should see this data dictionary. It should let us make it larger. There we go. So this gives us a little bit more information about each of those 29 rows and what they would mean. Also a more detailed description of the data set itself. So this really tells us where the data is coming from, what we can expect to learn, a little bit about the origin behind this data set too, if we wanted to know why it was published in the first place. We learn a bit about that there. We go to the column info tab, and it gives us the definition of each of the columns that we would see in the data set. Some of them are very self-explanatory. Zip code is the postal code of where the incident occurred. Accident date, the date that the accident occurred. So some of them are quite self-explanatory. But of course, some are a little bit less intuitive, and that's where it's helpful to use the data dictionary. I also see this diagram, kind of a cool way to see how this data set links to other data sets that also exist on NYC Open Data. So like this is a data set that specifically looks at individual crashes, but there is another data set that compiles a list of vehicles involved in crashes. And each data set has a primary key. So in this case, the primary key is the collision ID. And for each individual crash in this data set, the main identifier for that individual data point would be collision ID. That's the primary key. That primary key also corresponds to a collision ID key in another data set that's looking at vehicles. And in that case, in that data set, the primary key for each vehicle involved in that data set is unique ID. And we could also see that that would be a secondary key in a third data set, which is looking specifically at persons involved in crashes. In that case, each person would be a data point assigned the unique ID as their primary key. But if we wanted to look up the corresponding collision or crash that was involved in that data set, I guess, or in that crash, we could connect it to the collision ID that would then point us back to where to find that point on this current data set, which is confusing, but if you think about it for long enough, it starts to make sense. I promise. This piece, a little less useful, but so we're going to go back to the main data set, which, stop that guy. And then we want to share my screen again. Back to there. Okay. We go back to our data set. A couple things that we can do with the data. Again, it's 2.17 million rows of data. So to export it directly from NYC Open Data would probably be unfeasible. Like even Microsoft Excel, I think only lets you go to like 1 million rows. So we do have the option to export data from NYC Open Data, like into Excel, to Google Sheets, numbers, whatever you want to do with it outside of the platform, but some data sets are too large to export right away. So in that case, we can start with going to query data, which lets us kind of play around and filter the data, refine it a little bit before we export it out of NYC Open Data. So if we start, get out of the way, look at the data set as a whole, we can see it's really large. It's showing rows 1 through 100 out of 2.17 million. So we start with applying some filters, and the filters build upon each other, which is a really useful way to narrow the data in a meaningful and directed way. I'm going to start with borough. So I live in the borough of Manhattan. So we're going to look at crashes that occurred in my borough of Manhattan. In this case, the specifier automatically populates to as one of. I'm going to change it to is because I only want to look at crashes in which the borough is Manhattan. So add that. We will come down here and click apply. And it automatically filters to all the crashes that occurred only in Manhattan. And right away, we can see that it's reduced the size to about 333,000 out of 2.1 million. So we're getting smaller. I may also want to look only at crashes that occurred between a certain range of dates. So I can go to crash date, and let's look maybe 2 weeks back. So we might want to say only crashes that occurred between April 14th and April 28th of this year. And in that case, the is between specifier makes the most sense because we're looking at a range between 2 dates. So we can hit apply again. And so now we're looking only at crashes that occurred in the borough of Manhattan between April 14th and April 28th. And now we're down to just 181 rows of data. So we're getting to a digestible point. Can further, just to demonstrate other potential specifiers here, we could add a column For example, if we wanted only to see crashes in which there were at least one resultant injury, we could select number of persons injured. And in that case, because we want to specify that it is at least one, we could say, you could either choose is greater than 0 or is greater than or equal to 1. Both get us the same result. So we'll say is greater than 0, apply again. And now we're down to just 72 results. So there have been, according to this data set, 72 crashes that resulted in at least one injury between April 14th and the 28th in the borough of Manhattan. If we wanted to export that data set and continue to work with it outside of NYC Open Data, we just click on export, and then we can select what format we'd like the data and download it directly to your computer. Alternatively, the platform does let you visualize data without actually exporting it. So we could go back to this primer page for this data set, go to actions instead of query. This time we're going to go to visualize and then create visualization. Not going to sign in. And this lets us do a lot. So as we see, there are several different options for ways that we would visualize the data. Again, because this data set is so large, we want to apply some filters first. Otherwise, it will take all of an eternity to load and probably not be very meaningful. The other nice thing about applying filters is that as soon as you start applying filters, the website starts loading the data. So it means that there's less load time on the back end when you're actually ready to visualize. So we're going to first say for filters, let's apply, not time, remove that guy. We're going to start with the date filter because that will let us look at, not time, add filter, crash date. All right, so we're going to look probably around the same date range as we did before. Let's say between April 14th of 2025 and the 22nd, which is probably, we'll go the last 10 days. So apply this date filter, and then we have to decide by which dimension we'd like to visualize the data. I'm going to start by selecting the borough dimension. So this is going to show a visualization of every accident or every crash broken down by borough between April 12th and the 22nd. It automatically populates to a bar graph, and we see that the greatest number of crashes occurred in Brooklyn, the smallest number occurred in Staten Island. We can highlight each bar to see the exact number of crashes that occurred in that borough between our specified dates. Other ways that we might want to visualize the data would be, for example, a pie chart. So we can hover over and select the pie chart option. Again, it's roughly the same data, just displayed in a different way, but each piece of the pie corresponds to one of the boroughs, and it gives us the exact number of crashes that occurred in that borough. One kind of interesting caveat is if we notice that this orange slice of the pie says no value, this is because, and it points to the very human element of what we're doing. Each crash in this data set had to be entered by a human, and for a certain number, the human failed to enter a borough in which that crash occurred. So we can see that within the last, or within our selected 10 days, there were about 423 crashes in which the person entering the data just didn't fill out the borough specifier. So we could filter that out or remove that slice of the pie if we wanted to, but it's a a good reminder that there is a human element to all of this. Other things or other ways that we could visualize the data would be, instead of looking at boroughs or crashes by borough, we might want to look at trends over time. So we would broaden our date range because we'd probably want to get more data than just 10 days worth. But we could, for example, we could even go all the way back to April of 2012, which I think is a little before this data set. We'd probably have to go, but it'll start automatically exactly 11 years ago. Again, a pie chart is probably not the most useful way to look at dates. So we're going to select crash date. Scroll down, crash date will be our dimension. Again, we've broadened the filters so that we're looking at all the dates going back about 11 years. We've selected crash date now as the dimension. And then obviously we need something other than a pie chart, but a timeline chart is a helpful way to look at dates. So this shows plotted on a chart over time. We can see that the y-axis corresponds to the total number of crashes in all boroughs that occurred on that date. The x-axis is the date. And as we move from left to right along the x-axis, we can see how the number of crashes changed over time. Interesting things to note, like we see a really sharp decline right about here. And if we hover over, we can see that it really begins right around like February, March into May of 2020, which we all remember was the beginning and really the worst of the COVID-19 pandemic. And it is interesting to see that there was a really steep decline in crashes that occurred as the pandemic was ramping up. Also interesting to notice that it never really rose back to pre-pandemic levels, that since early 2020, the total number of crashes has stayed significantly lower than it was pre-pandemic. And then there's even a little bit of a drop off here again in the last couple of months. And it's interesting to just think about what might have been behind that. I know New York City has been looking into a number of initiatives to reduce accidents. We've been introducing bills for daylighting. Also, the congestion pricing that took effect pretty recently may be correlated. But it's interesting to think about how those policies really do translate to real life data. Also interesting to see that there's every year, it looks like there's a decline in the fall to the end of February, and then an increase in March, which may be related to tourism, fewer people driving at all in the city in January and February, and then increases again in March. So interesting to think about how those things play out in real data. One final way that we may want to visualize the data is plotted onto a map. So this data set does contain a location point. So it would allow us to plot each crash onto a map. We'd want to start with refining our dates again, because if we plotted every crash between 2012 and now onto a map, it would be unwieldy. But if we looked at, say, a 10-day range between April 12th and April 22nd of 2025, because that's the year we're in, press apply. So this narrows down our date range. We're going to go back to the dimension tab. In this case, we are going to select location. And then we'll have to change our visualization again. Can't really plot locations on an XY timeline chart, but we could select map. That will load our data. And then we zoom in to New York City. And so this has plotted between April 12th and the 22nd. each crash as a point on the map. It's kind of an interesting way to see some trends, like areas where there are a higher concentration or a lower concentration. Zoom out again to see a bit of a bigger picture. But it does help to get a sense of places where there is a pedestrian or a cyclist or a motorist. It might be a little bit more dangerous or heavier traffic versus areas where there may be lower traffic. Just some of the multitude of things that can be done using NYC Open Data. I'm going to throw back over to Giuseppe, who's going to finish touching on some of the other uses of open data. Go to there we go.
All right.
Oh,
Okay.
we put in 2 slides, that's why.
Okay, so now we're going to take a step and now we're going to see what other ways we can use the motor vehicle data in a more specific way. So first things first, we're gonna go to the next slide. This is a subset of the exact same data set, but what makes it more specific is that this focuses specifically on the details of the vehicles that were involved in all these crashes. So that way, if you wanted to sort between which makes and models were involved in the most accidents, or if you want to see the inverse of that, which were the safest, then you could use this data set specifically rather than having to go through the much larger one. And then if we go to the next slide, there's a second data subset with this one focused specifically on pedestrians involved in crashes. May that be individuals who are just walking on the street, involved in the crash in general, in any vehicles or any cyclists. This data set focuses exclusively on that. So again, another way of getting to avoid the over 2 million points of data originally from that first set. So a really nice way of slimming everything down. And now moving out of the open data realm, we're going to look at this really cool resource called Crash Mapper. We're going to put the link in the chat right now. And pretty much what Crash Mapper is it is a consolidation of all of the crash data that was put into a third-party site and just allows for a very clean look that not only takes out all of the no value information, but it streamlines all of the filtering process. It puts everything right on one page for you. You got to manipulate based on any of the parameters you want to, some that are even not included in the open data set, such as the police precinct, the community board, and then some other cool aspects is that it also changes the coloration of a few of the points, showing how deadly some of the crashes were or how many people were involved in them, which is another just really cool quality of life update. Okay, now moving on to the next point, which is boundaries map, which was created by our friends here at BetaNYC. And the really cool part of boundaries map is that it shows the division of all the different New York City administrative districts. And this relates to crash data because if you wanted to compare directly between which districts had the safest record for traffic, and the lowest safety for traffic, this would be a really cool way of seeing that. And then you could also compare if there were any different traffic laws across the districts, note if there's any change in police activity across districts and how that impacted the traffic data. A whole lot of different things you could do with this. And then moving forward to how's my driving, ending on more of a fun one. This one wasn't created by any organization. It was created by an individual named Brian Howell. And this just goes to show you that any person can take any of the data provided by New York City Open Data and make something really cool. The way the site works is that if you have a license plate All you gotta do is throw that right in there and it will tell you every single traffic violation that license plate has ever accrued, every speeding ticket, every infraction. You'll know, and then you can finally answer how your driving is and stack it up to any of your friends if you want to compare. And with that, we're going to move into the Q&A session. If you guys have any questions that you want to have, you can drop them in the chat, or you can use the raise hand function. And then we'll unmute you, and then you can ask the question. But yeah. You can pause for a minute if anyone does want to ask anything. And it could be about specific data, why we chose the crash data, or it could be specifically about anything having to do with our walkthrough of New York City Open Data. Sorry, could you repeat that? I didn't hear you.
Oh, sure. Yeah, I didn't even ask my question. I was fiddling with raising my hand. I was curious, Kate, I know when you were going over the data dictionaries, you mentioned that I think it was the version history or update history is like there wasn't much useful information because it was blank. Oh, you can't hear me at all. That's odd. Can you not hear me still? Okay. But I was wondering just a little bit about what information tends to be in that field and in that page in the data dictionaries.
Sorry, well, we just figured out what the issue was on our end. So if you could just
Okay,
repeat
sure.
that one more time, we'd really thank you.
Sure, yeah, I'll say it again. So just when Kate did the initial overview of the data dictionaries, there was one tab that you mentioned. There wasn't anything in it in this particular data set. I think it was like the update history or version history. But I'm curious, I can imagine for some data sets, there's some really valuable information there about, how things have changed over time. Particularly, I imagine for like older, yeah, maybe it was revision history is the piece. So I was just wondering if you could talk a little bit about that and like what you see in other data sets or, what information someone might be able to dig around and find. And if there's any interesting examples that you know of.
A really interesting question. I have not played around with other data sets enough to know really what's in their revision history, but it is a really interesting kind of thought experiment and something I'd like to look into to see like what does this page look like in other data sets. So I'm only super familiar with this one, but I'm sure that if you looked at other data sets, this would populate pretty differently. Yeah, because in this data set, it's not giving me much useful information.
Thank you.
We also do know that there was a effort to digitize all the information. So there was a transition period between when everything was done by hand and reported by an individual over to when everything was run through by a computer. And an example of a little bit of the disconnect that happened from that could be represented in the revisionist sheets would be all of that no value data we looked at earlier when it came to the boroughs. Just a little bit of a mishap that will probably be looked at sooner rather than later, hopefully.
Mm. Cool, thank you.
All right, if there are no other questions, then we can move on to the very end of the presentation of the class.
I think Hyojin's hand is up too.
Hi, sorry, it took a while for me to find the raise hand icon.
Yeah, what's your question?
So, just I guess I'm a little confused how to read this data set. It's not, I'm just trying to figure out how to say it correctly. So the collision like the crash vehicle and the person, it's not necessarily shows who was the cause, right? There is a victim, but we don't know which one was like we don't know the cause of the accident.
So actually, there is a subset on, it's just buried in all of the rows, but there is a categorization of what the cause of each accident was. Off the top of my head, I can remember if there was a phone involved, distraction, somebody fell asleep, if there was a substance involved. Um, and I also believe that it's listed on Crash Mapper as well, if it isn't found easily on the New York City Open Data set. So there is a lot of information on here, but since it is in its raw data form, it does have that like big obstacle of navigating it, especially if you don't exactly know where to apply the correct filters. But that's why like resources such as Crash Mapper are super useful because they take a lot of the heavy lifting out of it and just let you manipulate and utilize all the data visualizations that you want to.
Right. That makes
Yeah, so
sense.
for each of the points in this data set, there are up to 5 contributing factors. And those off the top of my head are things like alcohol, phone use, substances. And so not every crash in the data set has any contributing factors listed, and I don't know exactly why that is. But if I believe that if contributing factors have been identified, which may or may not point to fault, that they would be included into that data point.
Gotcha. It's just that I was working with this data set and reading the what do you call data dictionary. Like it was a little bit confusing because let's say the crash, I guess I was looking at a different one, but because there's like multiple versions, like right, like a crash, person, and vehicle, and the columns are a little bit named differently but have the same information across 3 different databases. So which one is the main one? Is it the crash, the one that has all the data?
Are you looking at the 3 data sets that are all in some way linked to each other?
Exactly, yes.
I wouldn't say that that any of them are a main data set. They're all slightly different, but they are related to each other. So for example, this data set, the main thing that you're looking at are individual crashes, not individual vehicles or individual persons involved. So the data points, the crashes themselves may correspond to other data points in other data sets. And so, for example, if there was a crash, say on Bleecker Street on March 1st at 5 p.m., that data point would be included in this data set, but it would also probably be included in 2 other data sets. And the keys allow you to identify which points exist in more than one data set. So if I was looking at this data set and I was looking at the vehicles data set, and I saw that they both contained a crash that occurred on Bleecker Street at 5 p.m. on March 1st, the keys allow me to line them up and recognize that those 2 represent the same crash, not 2 different crashes that happened to occur under very similar circumstances.
Oh, great. This makes more sense now. Thank you for your explanation. This makes sense.
Good.
And then Carolina, what's your question since you raised your hand first?
My question is, if you could give some examples, some good examples of how journalists are using not only the crash database, but other databases you have, just for a way to illustrate.
Honestly, I feel that journalists aren't utilizing this information enough. Um, there's a really big push now that there's a lot of distrust in the media, and I feel that, and obviously this is just opinionated at this point, but I feel like it's because they aren't utilizing resources such as New York City Open Data or other data dictionaries, things that back up what's being said through legitimate facts and just genuine proof. So I feel like if there was a transition to get journalists to utilize these resources a lot more, then I feel like it would really provide a strong foundation that would benefit everybody involved. New York City would have more attention brought onto the data and other resources that it provides, and the basis of what a lot of journalists talk about would be a lot stronger.
Interesting. So there is a need, a niche on that is being maybe being overlooked. Journalists are not using as much as they could. Good to know. Thank you. I appreciate your answer.
Yeah, and then Daniel, what was
Hey,
your
just Giuseppe, I actually want to hop in real quickly and say we run Hi, this is Noel. I'm the executive director of BetaNYC. We run a week of dedicated to the city's open data law, where we have countless journalists talking about their use of open data. Just as an FYI, so you can take a look at archive.open-data.nyc. And you can see excellent examples of local reporters, researchers, activists, even city agency, like everyone, archive.open-data.nyc.
I saw the one up with the top 4 or 5 data journalists, and that what actually inspired me to be here.
Yeah. The archive.open-data.nyc is where you can see all of the historical videos from Open Data Week and School of Data. And broadly speaking, we have some really great journalists in the city that use open data to tell their stories. But once again, it's not as we wish that like every story was data driven, but not every journalist has the tools. And this is something that we like to present and make sure that there were more stories. I just wanted to hop in and give a plug for Open Data Week and the archived videos on archive.open-data.nyc. And please, take a look at the videos that we have published for last year. We're currently in the process of uploading the videos from this year. And I just wanted to throw that in there right now. Thanks for letting me hop in.
Thanks, Noel. And then Daniel, what's your question?
Yeah, thanks. Just really quickly to respond to the previous questioner, Streets blog does some really good reporting, and they have some recent reporting that looks like they were pulling from not necessarily this data set, but there's this sort of speed camera data set, and I just want to call them out. My question is, I've looked at the crash data before, and I know there are a few columns for, like vehicle 1, vehicle 2, vehicle 3, and there's also a couple columns for like pedestrians injured, pedestrians killed, etc. My question is, how does that relate to the vehicle and persons data sets? Are those just sort of summary fields that get calculated? And if you pull up the persons data set and there's a you look at one of the crash keys, all the people there will just have sort of demographic information, but they will also be tagged with whether they were a pedestrian or a cyclist. And will that have whether they were killed or injured or the extent of their injury? Yeah, that's sort of like the relationship between those fields in the crash data and these other data sets.
Yeah, I believe you are correct in your assumption. The pedestrian data set would focus more specifically on all the information that was collected based on all the individuals who were involved in the crashes. And then the same would be the vehicles, where it is a smaller list of the larger data set that is hyper-focused on those 2 specific points. Just because the data set's so large, it's a means of filtering it without applying any filters originally at first. Just because I know for especially older computers, they could struggle a lot with managing all of the raw data at once. So it would be a way of just stepping down the just amount of information to be processed.
And what kind of information is in the person data? Is it demographic, or what's the level of detail there?
I don't believe that there's identifying demographic information in any of them. This is the vehicle data set. So if we start at the left over here, so this unique ID that identifies every point in the vehicle data set corresponds to a collision ID, which would be the first line in the crash data. So like this point right here also appears in the crash data set. And this collision ID is how we line up knowing that this collision in this data set is the same one as this collision that occurred in September 2012 on the crashes data set. It gives a little bit more specific information about the vehicle itself. So it does identify like the state registration, the vehicle type, make, model, year, in some cases, travel destination or direction, vehicle occupants, the gender or the sex of the driver. I don't know why most of the driver license statuses are blank, because I presume that most people who are driving are licensed to be driving. But presumably, if someone was unlicensed and driving, that might, hopefully would appear in this column. The issuing jurisdiction of the driver's license. So it gives us a bit more specific information about the vehicle, like where there was damage, if there was damage on the vehicle. And of course, it can have up to 7 or 6 vehicles involved in each accident. And then again, there are, in this case, there's only one contributing factor listed, because if we remember on the crashes data set, there's one contributing factor per vehicle. In this case, because each vehicle individually is a data point, there's probably only one contributing factor listed at all. In many cases, they're unspecified, but sometimes it's things like an illness. It might be intoxication, failure to yield to right of way. So I'd expect a similar level of detail on the person's data set, which I probably could find. I think we have to look a little bit further down. So this is the one for persons. And again, so there's a collision ID that ties it back to the crashes data set. And it gives us a little bit more specific information, like was the person a pedestrian, an occupant of the vehicle, either injured or uninjured. For some, there's age. So there is some demographic information like age entered. I'm sure there wouldn't be enough to identify a person. Something akin to HIPAA probably applies here, but emotional status, type of injury, little bit about safety equipment. Of course, it's not populated in most cases, but it gives us a little bit more information. Pedestrian location, pedestrian role, so whether they were the driver, and then again, contributing factors. So each data set gives slightly different information depending on what you're looking for.
Alrighty. And now we're just going to end off this class with a few ways that you guys can stay involved. Okay, so first of all, I want to touch really quickly on the New York City Open Data. Can you go to the next slide, please? Thank you. On the New York City Open Data Help Desk. So if you go to the homepage of the New York City Open Data, you'll see all the way at the very top a big Contact Us tab. And what that's going to do is it's going to put you in direct contact with an open data ambassador, who then will have direct contact with any and all of the entities that are responsible for the data posted. So let's say, for example, you wanted to report on an issue with the crash data, you would go follow the Contact Us tab, put in all the information required, and then that ambassador would put that information request directly into the hands of the New York City Police Department. And then there would be process where they overlook everything, and then they can correct any of the issues that needed to be addressed. And that would go for and then that would go for any other government entity or agency that is contacted. It just all happens through the Open Data Coordinator. Okay. And another cool point, if you can't find the data that you're looking for, you can also request a data set. And if there's data at all that meets the definition of whatever New York City Open Data is, then the agency that manages it is required to respond with an estimate of when the data will be made available or public, or why it can't be shared. And finally, just some other cool things happening in the New York City civic tech community. We're going to drop a bunch of links in the chat. First is going to be the BetaNYC links. That's going to have videos from previous Open Data Week festivals. And there's going to be another link for that as well. And then also upcoming, we have an Open Data Week spring meetup this upcoming Friday, May 2nd. It's going to be a really cool event showing where everyone is at the transitionary period from this previous Open Data Week, moving on to the next one, any cool developments happening in the tech and data field. And then just talking about a little bit more of what Open Data Week is. It's an annual festival of community-driven events about New York City Open Data, produced by New York City Open Data team and us over here at BetaNYC. And it includes events ranging from workshops, panels, showcases, data-informed art, scavenger hunts, collection expeditions, a whole bunch of really cool stuff, all involving data. So I couldn't recommend it highly enough. You can visit open-data.nyc, which we'll put in the chat as well if you want to learn some more about that. We also have School of Data, which is BetaNYC's in-person conference that happens during Open Data Week as well. It brings everybody together to learn everything about data in a jam-packed day, which is also really fun, a little similar to this class we have right now. We also have Beta Bagels, where New York City offices present their recent and upcoming work that has to do with technology, data, and design. And of course, we have the Open Data Ambassadors, which a subsect of this class was based on. And finally, I just wanted to thank all you guys for coming out today. We're going to send you guys an email, the version of the slide deck, and a quick summary of everything we went over today. And yeah, that's it. That would be the end of the class. And again, just wanted to say thank you guys for coming. It was a really great time having you all here, and we really appreciated you spending time with us.
Thank you.
Indeed. Thank you so much. Yeah, as Giuseppe said, if you have any data inquiries, feel free to send them our way. But otherwise, you guys were wonderful. So thank you.